Hi, everyone. So this week we're looking at Chapter 11, Threats to Internal Validity. Did the independent variable really cause the difference? So we're continuing to build on all of the things that we've talked about, and several of the things in this chapter we're kind of elaborating on from a previous unit. But we'll look again at some of the threats that we discussed in Chapter 10. We'll talk about the really bad experiment, a cautionary tale, something that's covered in the textbook. 6 potential internal validity threats in one group or pretest post-test designs, 3 potential internal validity threats that we can find in any experiment, and then finally kind of wrap up with if there are so many threats and so many potential issues with an experiment, are they still really all that useful? So those are some of the things that we will look at in this chapter. This is something we talked about before. So 3 threats to internal validity that we covered last week in chapter 10. So these were previously discussed, but we can have issues such as design confounds, selection effects, and order effects. So remember, these are all threats to internal validity. Was the research done right? Did we set it up correctly? Can we actually infer cause and that one thing is causing the other? Design confounds were when another variable varies systematically with the independent variable, which can confound or kind of confuse our results, make them very unclear. Selection effects are when different independent variable groups have systematically different participants, very common in independent groups designs. And order effects were when we have changes due to the order in which the levels of the variable are presented, which is common within group designs. So these were 3 things that we talked about previously. Again, we can have confounding variables and designs, things that are causing issues that are due to selection effects, and then things that cause issues related to order effects. So the textbook talks about something called the really bad experiment, also known as a one group pre-test post-test design. Now, if you look at this graph, right, it's going to look strange. This looks like a correlation, right? There's only one group present. Whenever you're doing an experiment, you have to have a comparison group. So if we're ever talking about a research design or an experiment where it's one group and there's no pre-post with a comparison group to counter, it's going to be a bad experiment. Right, so if we have, they have this example here, the participants take a pre-test measure, there's a treatment, and then a post-test measure, but there's no comparison group. And so it's really important whenever we're doing an experiment, you want to see another line here, right? We want to see what is the difference between the different conditions or the different groups that are present. One group is likely a problem. And we can look at this in a couple of other ways, some other things that are talked about in this chapter. 6 potential internal validity threats that we can see in one group pre-test, post-test designs. So these designs are very vulnerable to quite a few different errors or threats to internal validity. So let's look at each one of those. There are 6 of them: maturation threats, history threats, regression threats, attrition threats, testing threats, and instrumentation threats. Instrumentation, that's a tough one to say. So we'll look at some of these different threats to internal validity that we would see, especially in something like a pre-test, post-test, one group design. So maturation threats are one thing that we commonly can see, right? And a maturation threat is when there's a change in behavior that emerges spontaneously over time. Now, you would see this quite a bit, especially in maybe something that was a long-lasting experiment or a long-lasting study, that people are likely to just kind of evolve or change or mature over time. Processes such as growing older, growing stronger, or even maybe growing tired and more impatient as the research progresses. And the easy way, and you'll see this constantly in this chapter, the easy way that we can prevent a maturation threat is to add a comparison group, right? If we were to compare our group to someone else, then we can easily identify and hopefully isolate out some of the elements that might have occurred just to kind of spontaneous changes that might occur over time. We can also have history threats to internal validity, where an external factor affects most members of the treatment group. It's a systematic effect that happens across everyone. So if we have our participants and then we do a pre-test measure. There's some kind of treatment, but then something else in there happens. And then we post-test or measure it, right? So maybe there's something that happens that is like a very kind of global thing, like COVID hits, and it changes the way that everything is occurring for everyone. There's some other kind of global systematic effect or external factor that's going to affect most of the members, if not all of the members of the treatment group. How can we prevent a history threat? A comparison group. Again, you'll see this over and over and over again. If we add another group that we can compare one group to another, then we can eliminate a lot of these internal validity threats. So you can start to see the importance again of having that comparison group and having those multiple conditions. There are also regression threats to internal validity. A regression threat we sometimes call regression to the mean. If the group mean or average, another word for mean would be average, is unusually extreme at time 1, time 2 or measurement number 2 is likely to be less extreme. Very fun, I get to bring in football here, which doesn't happen nearly often enough. There is something called touchdown regression. And this is something that the statistical analysts for fantasy football talk about constantly. A couple of seasons ago, Atlanta Falcons player Julio Jones, who's one of the best wide receivers in the league, did not score hardly any touchdowns. It was almost a long-standing joke over the course of the season. He would have 200-yard games, which is absolutely an incredible number of yards, but he wasn't scoring any touchdowns. And so the analysts kept saying, this is an outlier. This is totally an extreme situation. He's likely due for some touchdown regression. It's unlikely that the combination of random factors such as injuries, weathers, a captain being sidelined, like for example, in a Germany versus Brazil soccer game, right? It's unlikely that that score would happen again. It's unlikely that Julio would go through a whole season and not score a single touchdown. And that definitely happened the following year. He scored a bunch of touchdowns, right? He kind of went back in the opposite direction. He regressed closer to the mean or the average. Very likely, if one measurement is extreme, that the next measurement would be less extreme, just because it's unlikely that those random factors would combine together to create that again. Another threat that we often see to internal validity is something called attrition. Sometimes when we do experiments, participants drop out, and they drop out systematically. So what can happen is you say you have a group of 500 people and you're measuring them pre-test and post-test. Maybe those participants, some of them drop out between the pre-test and the post-test, or before treatment or after treatment. And so preventing attrition threats, one of the best things you can do is to remove the pre-test score and the post-test score, right? So if that person, let's say we have 20 people who fell off, we remove all 20 of those scores from the research so that we don't have like a pre-test but no post-test for them. Or we at least check to see if it's close to average, but most likely we try and build in for things like attrition. And if people drop out, we hopefully still have a large enough sample that we can still get good data. But it's something that happens for sure in experiments that people start them, but they don't always finish them. We have this dropping out systematically that can be a little bit problematic in terms of our data. We can also have testing threats and instrumentation threats. Testing threats is an order effect. Maybe people are exposed to the dependent variable test twice, so they do better because of practice, or maybe they do worse because they're bored. We can prevent this by doing a post-test only, having a comparison group, or different forms of the dependent variable, like different questionnaires. But sometimes when we test people multiple times on an instrument, they become bored with it, or they answer in a very like lazy, kind of non-committal manner, or maybe they do better because they've at this point been exposed to it more than once. So we could try and change it up by using different tests that measure the same thing, or maybe only adding that comparison group so we're not looking at people multiple times on the same instrument. We might also have what's called an instrumentation threat, where a measuring instrument changes over time. Maybe we develop an instrument that we want to use or a test that we want to use for our experiment, but we have to change the standards of scoring, or the pre-test, post-test forms of it are not equivalent. Sometimes the instrument has to change. Maybe it's no longer available, or we find that it's not working for us. But that would be an issue or a threat to internal validity that's based on the instrument itself changing over time. So the instrument changes versus the participants have changed, right? Are kind of two interesting things to distinguish here, right? With an instrumentation threat, we have the instrument or the test use that we're doing changing, versus a testing threat, the participants themselves have changed. There are also 3 potential internal validity threats that can affect any experiment. I love this, right? So if it's good, it's Mr. Coffee, and if it's bad, it's me, right? Right, coffee facts. But with this, what we have are sometimes the observer can influence the interpretation of results. There's something called an observer's bias that can happen in experiments where the researcher's expectations, or what they expect or hope to see, can influence the way that they interpret the results, right? Or on the other end, so that would be the observer or the researcher having kind of an issue with their expectations and bias. But we can also have on the flip side something called demand characteristics, where participants guess what the study is supposed to be about, and they maybe change their behavior or skew their behavior and responses to act accordingly. Especially if you have a group of psychology students, they might have caught on to what the research experiment is about, and they kind of act in a way that might be, they think is in demand or more characteristic of what they were looking for in the experiment. A couple of ways that we can try and control for observer bias and also demand characteristics. We can use a double-blind study or even a masked study. A double-blind study is when neither the participants or the researchers know who is in a treatment group or who's in a comparison group. So it's blind in the sense that someone is in a group and they don't know, right? So they don't know if they're in the active treatment group or maybe the control comparison group. And so they don't have such a strong influence on their behavior. And the researcher, because they don't know as well, might not treat the groups differently. They might not look for a result or have an influence of their expectations. We can also just do what's called a masked study, where maybe the researchers alone are unaware, where participants are assigned a number or a condition and the researchers don't know, which would address the observer bias by itself. So we can try and manipulate things a little bit to hide the true intentions of the study, hide the different groups that people are in, and what that can do is help control a little bit for these different internal validity threats. We can also see something, and this is very much along the same lines, something called the placebo effect, where recipients believe that they're receiving an effective treatment, so they improve. They reduce their real symptoms. It's both psychological and physical. So for example, let's say that we give people an antidepressant versus a placebo, right? So we have people in different groups. One is going to receive the actual antidepressant, one would receive a placebo, but the placebo group, right, is going to show improvement as well because they believe that they received the antidepressant. Placebos are very, very powerful. If we believe that something is going to happen, we can produce real psychological and physical changes in our system. And so that expectation can be a very powerful effect. It can also be very negative, powerful in both a positive and negative way, where people can make improvements, or maybe they develop symptoms because they believe that they received the medication that had side effects. And one of the best ways to control for this, kind of building on what we just talked about on the last slide, is a double-blind placebo control study, where we don't know, the participants and the researchers don't know who got the placebo and who got the real effect. Right. And again, placebos can be a very powerful agent. And so trying to control for who knows and who doesn't can alter the way that people perceive the results and also perceive the effects of the potential drug that they may or may not have received. So as you design your experiment, right, with all these different threats, are experiments still useful? There are a lot of different threats to internal validity. But if you consider these things when you are making an experiment, you can often control for most of them by using things like comparison groups and random assignment, You can correct for almost all of these different threats to internal validity. So as long as a researcher, you are considering the different threats that might be present and how you could correct and change and alter them, you can oftentimes kind of eliminate the vast majority of threats to internal validity and make an experiment very powerful and very generalizable and so on. But every now and then, despite the fact that you've done everything well, despite the fact that you've set your experiment up well, you sampled your participants correctly, you controlled for all the confounds, you've done everything in your power, sometimes you get what's called a zero effect. Or in statistics, when you take a stats class, or if you've taken one, you'll learn this is called the null effect. The independent variable has not exercised any influence on the dependent variable. There seems to be no significant covariance or relationship between the two. So when you're looking at statistics, you're asking yourself, can I reject the null hypothesis? Is there actually an effect? And sometimes when we do experiments, there isn't one, right? And this can be explained in two different ways. The first one is exactly like it sounds. The independent variable has not actually affected the dependent variable, right? There's not any statistically significant effect between variable X and variable Y. The other explanation is that maybe the research wasn't accurately set up or performed. Maybe there is actually a relationship or an effect present, but we haven't designed the experiment well enough to actually capture it. Or maybe we missed out on some element of it or didn't control or kind of account for something which might have captured that statistically significant effect. So just something to be aware of, even if we set something up perfectly, sometimes there is no relationship. And when that's the case, you have to go back and look at, is there something I could have done differently? Or is it possible that these two things aren't connected? And in those cases, sometimes a replication study might be really helpful, repeating the study to see if you get the same results, changing things to see if that leads to a different answer, and then also doing a little bit more research and literature review to see where to go in your next steps. So that is everything for chapter 11. We're not covering all of it. Please make sure you pay attention to the page numbers that I posted in Canvas and on the syllabus. Also, make sure you do all the other required weekly materials before the deadline, and I will see you all next week for our next chapter.